department's undergoing massive changes in the last 4 or 5 years. We started an astrophysics program, and we've been fortunate to have been able to hire some fantastic young faculty. They have burgeoning research programs, taking on lots of students, they're getting lots of research grants. We're a small department with a large impact in research nationally and internationally. And that distinguishes us from some of the other peer institutions.
I've been to 3 departments: Michigan State University, Johns Hopkins. I worked at 3 departments, and this department here, out of all 3, this department stands out in how much effort we are willing to put into the education and the research experience of undergraduates. Almost every undergraduate is doing research with a faculty member, and I think it's very important for their education.
The success for people in the department for getting these types of awards really shows how dynamic these people are, and how they're really interested and put a lot of effort into doing not just research but also teaching and outreach and really furthering education goals. And that's one of the nice things about being in sort of a smaller department, is that the issues of education are not completely separated from issues of research. And I think the department here is concerned about both education and research, and we take pride in doing both.
Our students do very, very well. We've been very proud of the training our students get here. WVU strives to engage them in research as undergraduates, so they often get into the top graduate schools in the country or the world and have very successful careers. So we like to think that our students are very well trained and we're very well positioned to have an impact in all these very exciting areas of physics once they get their degree here. Across our core areas, condensed matter physics, astrophysics, and plasma physics, those 3 areas sort of encompass the whole range of physics research. So our work in the physics department here spans everything from the fundamental questions of why we're here, how's the universe work, to thermonuclear fusion experiments, to how the sun works, to how the plasma around the Earth interacts with the plasma emitted from the sun, from the solar wind, to how can you get more images on that hard drive, pictures of your kids that you've now taken for 30 years, and you really need that terabyte drive and not that 10 gigabyte drive that you used to have. I mean, how do you pack that information into a smaller area? The department itself is planning to move into a new building, or renovated building, at the top of High Street. The Whitehall building will be converted into a physics building. We hope to move in August of 2011. And a new building will have lower vibration, better temperature control. We'll be able to do more precise measurements. We think our program will grow, both undergraduates and graduates. A new building will add a lot of focus on physics, and we're excited about that opportunity. So at the close of the 20th century, beginning of the 21st, physicists are pretty sure that we don't know anything at all, that most of the universe is stuff we don't know. So isn't it an exciting time to be a physicist? If you're interested in trying to figure out what the universe is even made of, a fundamental question like that, it's a pretty exciting time.